Good morning, this is Padala Kiran Kumar from Mechanical Engineering Department with admission number MEB 18055. We are in the NSS workbench. We are going to use the fluid flow fluent to show the computational flow, supersonic flow over the wedge. And here we are going to use the fluid flow fluent and we are going to formulate the question. This is the analysis setting. This is the due box for the errors, and this is the properties bar. Here, that is the workspace. That is the workspace, and we are going to use the fluid flow fluent. Right click and a new analysis systems and a fluid flow fluent. On right clicking, on double clicking that, the fluid flow fluent will be opened. Waiting for it to open. Now there we can see the fluid flow fluent, and we are going to open the geometry first. And there it is. We are going to firstly mention here the 2D laminar flow of on a through a wedge. We are going to show that on the fluid flow fluent, and now let's go for the geometry. And the geometry is going to open. It's taking some time. Yeah, here is our geometry where we are going to make it, and I'm taking it in the millimeters. It depends upon us. It is our wish to do. And after that we are going to click OK, and XY in a XY plane, and we are going to bring it to our direction so that easily we can make it. And rectangle, firstly I'll draw a rectangle, and if you have the problem of that, we can click on escape so that we will be going out of that. And then we are going to now we are going to select a line, and we are going to draw that on the position, at some position to form a wedge. And then we are going to modify and trim the unwanted thing out of the image, and then we are going to trim it off. And after that, dimensions, we are going to give the dimensions, and then length and distances, we are going to give the length and distances from selecting of the opposite points. Means that we are going to select 2 points, and then we are going to get the length or the distance between that. And then we are going to give the length and distances of all the 4 sides, and then the angle will be 15 degrees at the, as we know, it would be 15 degrees. And then now we can see over there the line 1 2 3 4. And now we are going to give our own dimensions to that. 0.5 to L2, and we are going to give L1 as 1.5, and L3 as 0.991, and L4 as 1.259 all over in mm. And then we are going to zoom it up so that we can see the clear image of the wedge what we have drawn till now. And then I'm zooming it so that we can have a clear view. And then we are going to look at the measurements, each one what we have taken: 1.5, 0.5, and 0.991, and 1.259. And then I'm going to move it a bit so that I can have a clear one out of that. And then we are going to take these wedge measurements were calculated by us, and this was working on a parabolic equation in which the after points were affected if there was any disturbance. And the slant one over here, this was at 15 degrees, and this was the wedge. This will act as the wedge, and also the wall of it. And now we are going to going for the concept, and we are going for surface. And then Here we are going to in the actual plane in the sketch one we'll apply on the base objects, and then we are going to generate, and we got the object. And now we are going for the one part one body and surface body, and now we are going for a new sketch 2. And now in the sketch 2 we are going for the stretching, and here we are going to draw a line from one point to the other, a straight line. And a straight line, it would be like an altitude, a straight line. And now we are going for the straight line, and we are selecting the lines, sides, actually the edges. And then we are selecting the edges, and we are going for the concept. And now lines from edges, and lines from we are going for the lines from edges, and there we are going to apply. And there, look at that, there we got 5 edges, and then we got the 5 lines over there. You can see the 5 arrows over there. And then now we are going for the sketch 2, in which we are going to apply it of in the sketch 2. Look at there, we got the base objects, and we are got the base objects as at one sketch. And now we are going to generate, and on generating that we got the side of arrows on all the sides. And then after that we are going to concept tools, and now we are in the tools. We went for the projections, and now we are going to apply it on the one edge. And then we are going for the target, and target is the whole body, and we have applied on it. And then we got the surface body and the line body over here. We generated, and we got the surface body and line body, 2 parts, 2 bodies, surface body and line body. We don't need the line body, so we are going to suppress body. And now here, after this suppressing that, we are going to see line surface body, okay, it's visible, and the line body, okay, it was suppressed, and only one part. So from one part, it should be only from one part. And now it's totally completed. We got the whole project, means we got our we are going to save the file. Now we got the geometry exactly what we needed, and we have saved it. And now mesh, we are going to open the mesh now. Here on the mesh, the geometry was opening. It was taking a few minutes. And now in the mesh, we had the object what we have made, the geometry. And now we are going to have a dense mesh, and now we are going to insert it on the edges, and we are going to definitely have a dense mesh. And we are going for the sizing actually, and then insert sizing. We are going to select a side, means by going into that option we are going to select an edge, and now apply. And then we are going for the size, element size, number of divisions, and number of divisions we are going to have 100. And then bias type, we are going to select the bias type, and then bias factor, it would be 50. We are going to take 50. And then okay, we have selected one edge, and we are likewise we are going for the other edges also. Okay, reverse the bias type, and now we are going for the mesh, and we are going to insert it on the other side. Now we are going for the sizing again, and we are going to select an edge, and we are going to similarly apply a number of divisions, and then 100, we are going to take 100. And then we'll go for the bias type, and bias type we are going to select one bias type, and then bias factor, it is 50. And then we are going to select the other edge also, and then we are going for the sizing again. Likewise we have done for the other 2 edges the same. And then we are going to take the number of divisions and 100, and similarly bias type, we are going for the reverse the bias type with bias factor would be 50, reverse the bias type. Then we'll be going for the face. We'll be selecting the face mapped mesh, and now we are going for it face. Okay, and then we are going to select the faces of the object, and we are going to apply it on the 2 faces. And now generate mesh. We'll generate the mesh now. We'll get the wanted one, what we have wanted, the dense mesh. dense meshing. We are going to do that. Look at this dense meshing, are very dense meshing using, we have all the uses, the sizes and all. Look at, now we are going to have a zoom look, means I am going to zoom the dense meshing we have done here. Look at that dense meshing what we have done here. Look at that. Okay, and now I'm going to move it down. Look at the dense mesh. Okay, we the specific measurements and all we have taken for that. And now I'm going to give it the name selection for the edges, means these name selections are very sensitive. We have to name them correctly or it will be a grave mistake for us. And now we are going to select the edges 1, 2, 3 and the fourth one, and here these four would be named as the pressure far field, and create the name here, pressure far field. Remember once again, these are very sensitive. You should be typing them correctly. And now we will be, yes, FARFIELD field. Okay, and the other two edges, now we are going to select the other two edges also. Go for that option and click over here. Now this is the symmetry, we are naming it as symmetry, and then okay, click OK. And now this was the wall, we are naming it as the wall. Remember, this was the wall of the wedge, WALL wall. Okay, and okay, what we have done, we are going to save the project. We have completed our object correctly, geometry correctly, and now we are going back and update project. We are updating the project now. System is uploading the setup component in fluid flow fluent. We are updating the project now. It was taking few minutes to upload, and here look at this, all we have to do here, geometry, mesh, setup, solution and also the results, and then we are going to finish it up. Look at this, uploading is still going on. This setting, setup components and fluid flow, yeah, it's done. Right click to update the component, and look at here, we have going to it was ready, setup was ready, and we are going for it. We are taking the double precision. Okay, we are going to the setup now. Okay, this welcome to NSS 2014 copyrights and all that stuff over here. And now it was taking few minutes to open, that's right. Okay, here is the setup one, setup component of the object what we have done. Okay, 2D pressure based. Okay, and then pressure based, actually it's a compressed flow, so it would be density based, and it would be in a steady state. And then okay, this is a plain 2D space planner and models and all that. Adapt, we are going to the adapt option. Okay, boundary mesh, adapt the mesh. Okay, mesh. Okay, here we are not going to have that till, because we didn't done any calculations or we didn't took any inertiations and all that stuff. We are going to have that boundary adaptation and all that after doing the whole calculation and taking some measurements. Initially we have to do the calculations, have to take the measurements and all them and all that, and then we are going to have that boundary conditions and all that, and then also the gradient, we are going to look at that later. Now we are going for the models. Energy equation, it would be on. Okay, and then welcome here in the viscous model, it's inviscid, and okay, click on OK now, and then as you know, okay, and materials, air, we are going to take the air as the material, and then density, you are going to take ideal gas, and then here the specific heat, it's 1006.43 and molecular weight is 28.966. And here change, create and close, we are going to save them, right? And then here then the boundary conditions, we are going for the pressure far field and edit, and we got the Mach number as 3 and Gauge pressure as 101325, which is 1 atmosphere. Okay, and the surface symmetry and the wall, we are going to edit the wall. Okay, and operating conditions, which is 0 pascals pressure. Okay, and now we are going for the solution methods, solution controls and monitors and solution initialization. Here we are going for the standard initialization and pressure far field, and then initialize, and now calculation activities and run calculation. Here number of iterations 300 and calculation is going on, calculating the solution. Look at the graph over there, number of iterations, and the graph is quite moving down. Towards the y-axis, we can see the residuals, x velocity, y velocity, and also the continuity white line, and also the energy line, which is blue color over the graph. Look at that graph going on. It would be ticking up to 150 iterations, 300 iterations. Now the graph calculation is going on, calculating the solution. Okay, the solution has converged. The solutions are going to be converged now, and now the calculating the solution is still going on. Look at the graph. Look at the graph over there. Yeah, there was some ups and downs going on in the graph. Those are the residuals, 4 different colored lines: white, red, blue and green. X velocity, y velocity, continuity, and also the energy. Blue color line is the energy, and calculation is completed now. And animations and counter and the setup. Now we are going for the results, and we have filed and now going to display. We have the shock wave in here. This is the boundary conditions we have given: static pressure, pressure coefficient, and total temperature, total pressure also. Look at that total pressure, and now we are going for the temperature. Display the temperature. Okay, that's temperature. Okay, all static temperature also, and now velocity, display the velocity now. Okay, that's the velocity we have got, and now we are going to adopt the mesh now. Gradient adaptation, we are going for in the gradient adaptation, we are going to adapt. Now in the gradient adaptation, okay, we are going to get it. Okay, we have done apply, and now close. Now we are going again for the solution initialization, and in solution initialization, same pressure far field, and then we are going to initialize it. Okay, and then after that run calculation, same 300 iterations, and then calculation is going on. and in this case we have adapted the mesh. The mesh has changed a bit. The mesh has adapted in a manner to the gradient of the pressure. So before and after the shaft, the static pressure variation is there, so we adapted itself there itself over there, then dense. So we have an better shaft capture that will just have some difference going on now. After the calculation, we'll have a clear display of everything what we have done till now. Calculation is still going on. Calculating the solution. Okay. Waiting for the calculation. Okay. Okay, the solution has converged, and so graphics and animations setup, and now we are going for display of the velocity and also the velocity magnitude. We are going to zoom it for a clear picture now. Look at that. Look at the density we have got over there. Now we'll go for the pressure, static pressure display, and in the display zoom it up so that we can have a clear picture. We can now see the clear difference. Okay, look at that, and now we are going to move it down. Look at that. Two photos before and after adapting the mesh. Look at the clear difference over there. The mesh, how dense we have taken before, and the same was still over here. Okay, look at that. Look at that picture, clear picture. Just compare and see the difference. We'll see the very good difference. Static pressure gradient is very high. Let's zoom it up now. Let's see the clear difference. Okay, let's zoom it up. Okay, let's move it down. Okay, there it is. There the clear difference. We can see the mesh is so denser and a bit denser also, and the static pressure is also so high. Now close it. Okay, this is all we have got. Now we have totally completed it. Okay, we have done the computation of the supersonic flow over Wedge, and we have seen the solutions and also the results. And this is made by Padala Kiran Kumar, MEB 18055. Thank you for making me the video.